Okay, we're going to talk about acceleration here. Acceleration, as mentioned in my notes, is a change in velocity over time. So changing velocity over time. What I want to do here is just talk about notation here and how these two relate to each other with direction. Okay, if I had an acceleration, let's say, or pardon me, a velocity. Let's say an object was moving. I'm going to make it moving in that direction. So there's the direction of the velocity. Okay, it's moving in that direction. Suppose at the same time that object had an acceleration on it. And I'm going to make the acceleration going what's called parallel. Okay? So v is the velocity, a is the acceleration. If the acceleration is in the same direction, okay, this object would be speeding up. Similarly, if the velocity was in this direction, but the acceleration was in the opposite direction, that object would be slowing down. There comes another example here where all of a sudden the acceleration and velocity are not parallel and anti-parallel. What they are instead is perpendicular. So if the velocity was this direction, but the acceleration was perpendicular, what would happen here? Well, it turns out what happens here is that the acceleration doesn't go into speeding up or slowing down the object. Instead, it goes into turning the object. Okay, so I'll just say that the object turns. And if it was moving this direction, it would start turning like this. Okay, it would start going down and then around. It would start moving down. The object will turn, but it will not speed it up or slow it down. And recall that acceleration doesn't necessarily mean speeding up or slowing down. It means a change in velocity. In other words, if I change direction, even though I'm moving at a constant speed, I am by definition accelerating. Okay. Sometimes you get a mixture of these two scenarios here. And what does that exactly look like? Well, if I have, in an example here where I have a velocity, let's say pointing up, and I have an acceleration that isn't going to be 90 degrees and it's not going to be parallel or anti-parallel, but instead, perhaps it's pointing somewhat in this direction at an angle. What would happen here is that a part of this acceleration would go into speeding it up. And I'm going to draw it and break this up. And I'm going to say that this component, the vertical component here, would go into speeding it up. But this component here would go into turning it. So this object would partly speed up and partially slow down. Same thing would happen if I had a velocity, an acceleration, let's say moving like this. The same thing. Part of this would slow it down, part of it would turn it. And this, again, this one would turn in this direction, slowing down. This one would turn in this direction, speeding up. Okay, and that's like the relationship between acceleration and velocity.